I think we can start indeed. So thank you again for joining us today for this what I would call for the start of a series of workshop or lectures that we intend to launch with this particular workshop today. And indeed, we have realized that over the years in Eurospace, we have, of course, we have accumulated a lot of expertise, but also we have accumulated a lot of knowledge and of data. And we thought that it was actually only fair to share this knowledge with you, our members, because it was made possible, after all, thanks to your fees. So it was only fair to share this amount of knowledge with you. There is a second reason that is perhaps a bit more interested in. We have realized that sometimes when we struggle to push for policy objective, it's more often than not because there is a blatant lack of knowledge and of understanding of the space sector in Europe and about what's at stake. And so we hope, of course, that by sharing this information with us, with you, you will be able to use it and to spread this knowledge, this information towards your own institutional contacts. So it's not only about sharing information, but it has a practical purpose. Voilà. So without further ado, I will give the floor to Pierre, who I'm already thanking very much for the presentation today and for the amount of work and the years of work that what he will deliver today represent. So Pierre, you have the floor, and already thank you very much.
Thank you, Olivier. I just need to reshuffle a second because I see that the presentation which I have queued on my computer here obviously is the previous version, so I need to recheck it again. Let me close this. Well, I don't think this is any very major big deal. Yes, but this is not the right one. Just give me a second. Webinar. Okay. Webinar. September. Okay. Well, let's go like this. I don't know exactly why the versioning doesn't seem to be correct, but if there is any issue, we will correct that along. So thank you very much for joining in today. I see we have quite a few persons who have registered, so I appreciate the interest in the subject. We would like to make this an interactive presentation as much as I can. So the presentation is organized with a few chapters. So I will provide a general review of various data-based information on space markets. So I will move to a full screen presentation, and I will move this one to WebEx, share, and I will be sharing Microsoft PowerPoint. Can you confirm that you can see the presentation, Charles?
Yes. Yes, we can.
Yes, and is it in full screen?
No.
I think so, huh? Okay, let me click a few more things. Now, is it full screen?
Full screen. Yes, it is.
Very good. Thank you very much for the feedback. So let's say a few words about the contents. So the idea here is that I'm working on what I call a pompously conceptual framework. The idea is that I want to base all this demonstration based on data. So if there is no data, then of course we can discuss a matter, but it's difficult to present it in a sensible way. We have accumulated, as Olivier kindly recalled, a lot of data in the past years about, in particular, the missions that are launched in space. And we are doing a lot of research work to actually make sure that for each satellite launch, we can identify the mission, the type of customer. We have also designed an economic model that allows us to derive from the launch activity some market value estimates in PPP. The PPP is what we economists call purchasing power parities, which is a way to compare economic items across different economic models. So everybody knows, for instance, that in China, the average salary is much smaller than in the Western world. We also know that the Chinese money is actually controlled in terms of exchange rates. So if you want to compare China with Europe, you need to use a few tricks of the trade in order to make sure that something which is made in China and which you express in dollars can be compared to something which is made in the USA, which you also measure in dollars. And similarly, we do for Europe. So those market estimates in PPP are a complement of our analysis in mass and the global activity that we do. And it's a big added value because it gives a better vision of what is the economic power associated to space activities worldwide. Then we will discuss, as usual, something many people are very acquainted with now, the state of the competition with the differences between the captive and the open market. So the areas where actually we are competing with other industries worldwide and areas in which, regretfully, we cannot compete. At the same time, this is also protecting a share of our market, which guarantees for us a market where only European companies are really competing. A few words about China, the new space superpower. I think it is very important to spread this message because it is often overlooked, mostly because of the bad analysis which is done on European space budgets by the usual consultancies. So I think it's important to understand and spread this word because the paradigm, people saying China is so far below in terms of technology than Europe and the USA, so that we shouldn't be worrying about what they're doing in space. I think this is absolutely not true anymore. The new paradigm is indeed that China is a very rapidly expanding space superpower. They have a will to catch up on every count on space activity, and this is very clearly shown in the data I'm going to share with you. And then we would also discuss a little bit the quantitative assessment of the commercial markets in space. So basically, that will be the idea behind the presentation. There will be, I would say, a straightforward narrative which will bring you to embrace all the major elements of the assessment of the space market. But on top of that, I've also added what I call a few controversial and discussion subjects, which will be at the end. Depending on the time, we will be able to go through all of them, or maybe we can pick a few depending on what you prefer. So I will discuss a figure which everybody now has been exposed to, which is often referred to as the global space economy. The global space economy, as an economist, I call this a nonsense figure. Regretfully, I will explain why. The fact that it has become a benchmark doesn't make it better or more useful. Actually, this figure is, I believe, hurting the space sector more than anything else. We will review also the problem of global ranking of space powers' public budgets. Again, regretfully, this is a lot of nonsense. I will explain why. Then we will have a look, if you wish, at small satellite trends. My big question here, is there anything beyond Starlink? So far, actually, no. If you remove Starlink from the equation, well, basically, there is no small satellite trends. A few words also about what we call the new space. I mean, new emerging players in space. I will share with you what I call a few accurate metrics with details, and I will explain what I call the optical illusion of the Pareto principle. I would like to keep this as a point of suspense for the moment. And then, if we want also to discuss a little bit the question of launch cost, launch price, fill rate, basically what exactly is the situation, how do we understand the question of launch cost and price, and is cheap launch becoming a reality? Regretfully, I think that this is not the case, but if it were, probably it would be a game changer. So I would like to move to the next slide, but maybe I can stop and pause for just a second if there is any pressing issue that needs to be raised right now. If you really want to say anything, please raised a hand. I cannot see the hand raised, so Charles, can you tell me?
There's no hand raised, but there's a question in the chat. Please, could you detail the acronym PPP that was mentioned?
Yes, PPP is Purchasing Power Parities, and it is a system which actually uses economic tools to create basis of comparison between different currencies, which would not be the market exchange value of those currencies. So just a few methodological terms, because we need to understand what we're talking about. In space now, we usually hear a lot about the segment, which is called the upstream, the midstream, the downstream. What are they? This terminology is not really economically orthodox. Usually, from the economic point of view, we like to use market assessments looking at a type of product. So you have a type of product, and then you look at who is supplying it, who is buying it. So the core of most of microeconomics is understanding who is buying what from whom. The concatenation of all those market transactions into a logical flow creates what is often called a value chain or a supply chain, which, again, if I want to go to that subject again, this global space systems and application supply chain is often put now into a strange basket, which is called the global space economy. To define the terms which I will use in this presentation, which I believe are common also and shared elsewhere, usually we call the supply side, is also called the upstream. It is the sector that is building and selling the space systems. So it's companies like in Europe, Airbus, Ariane Group, and the such, but also the equipment providers, etc., which are defining and building the space architectures, the space systems in Europe. On the demand side, for those space systems, we have what I would call the midstream. So this is the type of economic operators which are buying and operating the space systems. So you see, you have an industry which is building a space infrastructure, and you have a group of companies which are buying and operating the space systems. And this includes in Europe such companies as Eutelsat, Inmarsat, SES, and so on. Of course, you have integrated companies. If I consider a company like ISI in Europe, they are procuring and building and integrating one part of their satellite infrastructure. They're also owning it and operating to deliver a service. So it's a kind of mix between the supply side, the upstream, and the midstream. This integration doesn't preclude the way that we do the analysis. And then further down in the value chain, you have what I call the induced market. The induced market is a typical economic term which identifies those markets for systems or services which are a direct economic consequence of the existence of the market of an upper layer in the same supply chain. So if there is a market for selling capacity in space, then there is companies which are using this capacity to deliver an additional type of service, such as the TV companies. Then, of course, there are induced market. If there was no satellite, their activity wouldn't be located in space. So those are induced market. Of course, there is also the market of the terminals, which is actually the biggest known market of all the induced markets from the space. And then we need to clarify another important point is that the space infrastructure, the satellites in orbit, the launchers used to put them in orbit, the ground segment which is used to keep them in operations and to perform the mission, all this is an infrastructure asset. So an infrastructure is an investment. And this is where the characteristics is very important. Typical infrastructure would be motorways, toll bridges, telecom networks, seaports, airports, etc. Those are large-scale infrastructure. The most usual analogy that we would make between the space sector and the non-space sector in terms of infrastructure is for the telecommunications infrastructure, which is very similar to the satellite infrastructure, which is very much dealing with data transfer and transport. And then there is the air transport, which is somehow similar to the space launch activity. Of course, there are limitations to the similarity. And what is specific to infrastructure is usually there are investments, not expenses, for those who are invested in accounting practices, the investments are not registered in the same area as expenses in the revenue and balance sheets. So an investment is registered as an asset. Usually those infrastructure have a long lifetime and also often have a long production time. So this is interesting to note. So there's multi-annual investment and multi-annual operations. And more than often, they are complex and expensive to acquire and operate. So this is the global economic settings that we have behind the space systems approach. And now we get into the first data sets. So here it's interesting to have in mind what has been the evolution of space activity over the past. So as you well know, space activity started in 1957, and then it developed pretty fast, and then it has plateaued, and then it has reduced its activity again, with a major drop in activity around 2002 and 2003. And since then, it is growing again. So, of course, this is very basic. What you see here is the total spacecraft mass which has been launched in space over time. It is sometimes considered a very crude indicator because, of course, technology in those satellites has evolved very significantly between the 60s, the 80s, the 90s, and even now. We still see technical evolution in satellites. But it's interesting to have an idea of this broad range evolution, because it is telling us a few things. The first thing that we would like to insist upon is that the Cold War has really fueled space development, mostly driven by the USSR, which had very low analog tech throughout the 60s, the 70s, and the 80s. So that created a very big space activity because the Russians were trying to match what the Americans were doing in space. But since the technology was not as good, they had to launch much more to achieve the same capability and results. And basically, this is what you can see. I don't know if you can see the cursor from my mouse, but it's seen here. The big development of Earth observation business in the 70s has been really driven mostly by the USSR and the launch they were doing of a lot of very analog satellites for Earth observation, which were quite expendable. And so they were really trying to catch up. With the digital introduction, so you have digital sensors notably, you can see that the level of activity related to Earth observation has really been driven down in the 90s, so that now we have a rather stable activity related to Earth observation. Another thing which is interesting to note is that human flights, which you can see actually in blue, have been, since the early 60s, a rather stable point of activity in space. So since the first humans in space, and through the Apollo program, the first space stations, up to now, and the resurgence of exploration programs, we have not really seen a big decrease in activity for human space flights. And this has been, again, a very strong point of activities of the past years in space. And what we notice now, another point of importance if we look at the global long-scale trends, is that telecommunications, which you can see here in dark green, the telecommunications program, are basically the new growth segment. You can see that the mass launch on behalf of telecommunication system has been growing quite systematically since the early 2000s. And with the 2 last years we have in the statistics, and with 2022 it would be even more. And thanks to the Starlink effect, this has been growing even more. So clearly, if you now think about space activities worldwide, well, basically, it's divided in 3 main blocks. You have everything which is related to human spaceflight, in which Europe today plays a very marginal role because we don't have the capacity to launch humans in space independently. So this is very much driven today by the USA, China, and Russia. And basically, its activities related to the two modular space stations that we have in orbit today, the International Space Station and the Chinese space station, the Tiangong. The second point of activity is really telecommunication, which is driving business growth in recent years. When I say business growth, of course, it is measured in volume, because we have the impression that this telecommunication segment is not really growing in value today. I will explain that later on, but it is a point of actual growth. And then we have Earth observation systems, which are the third point of activity. All other activities in space, when you look at them in quantitative terms, you look at scientific programs, you look at GNSS programs, you look at everything which is related to SSA, SST, operations in orbit, technology and test. All this represents a very small fraction of activity when you put it in the global picture. Of course, each sector individual can represent an important market segment for some players in the field, but in the global picture of space activity worldwide, those missions actually generate lower volume of deployment in space, and as a consequence, a lower volume of business for the related industry in terms of manufacturing of spacecraft and the launch of the same spacecraft. So you see the recent evolutions. Another thing which is interesting to note is that space activity was really very much developed in the late 80s. And what we see is that in recent years, 2018, 19, 20, and 2021, we have seen a regain of activity which is now exceeding the volume of spacecraft launched in space in the peaks of the late 80s. So this is also a major change. We are seeing more volume deployed in orbit than ever. This is specifically driven by Starlink and nothing else. Another thing which we have been mentioning quite a lot in the past is what people call a transformation in terms of satellite mass and activity. So here we see on the top layer here in blue, the average mass of satellites being launched every year. So you see that between 1957 and 2020, we have seen the average mass of satellites growing, and this has been driven by the availability of more and more powerful launchers, which have enabled to design bigger programs. And then starting in the late 90s, we have seen a reduction of the average mass of satellites being launched up to now, where this average mass is really being driven much lower. So we were in the order of 2 tons average mass per satellite launched in the years 90s and in the beginning of the years 2000. And now the average mass of satellites is about 350 kilograms. When you look at an average, of course, it obfuscates a lot of information. If you look here at the scatter, which is the representation, every dot here is a satellite launched in the year. And of course, when there are a lot of satellites with the same or similar mass, the dots overlap each other so that you have a more dense quality of color in the areas where we have the most of the satellites being launched. And clearly you see that the average mass reduction is not driven by the fact that current satellites are smaller and smaller. Some satellites have a trend to be smaller, and indeed we see the top level, the biggest satellites, not being so big anymore. But the reason why the average is going towards lower values is because we have more satellites that are launched, which are in a smaller class. And so this has an impact. But clearly we see here in the average mass the impact of two trends: a relative trend of stability, where large satellites remain large satellites and are still in the market today, but we see a growing development of smaller satellites at launch. And this is basically what we have seen with Planet, Spire, and other small satellite players in recent years. And of course, there is the very deep impact of Starlink satellite deployment on the global statistic, as well to a lesser extent of OneWeb. But when we look at the next chart, which actually you see the evolution of the number of large spacecraft. So for this chart, we define large spacecraft as spacecraft above 500 kilograms each. You look here at the number of large spacecraft which have been launched in the past, and you look at the total mass associated to those launches, basically if you look at the mass statistics at the bottom in orange, it's basically the same profile, more or less, as the figure of global activity. And this is because large spacecraft really influence the market much more than small spacecraft. That's because the volume of small spacecraft, if you remove Starlink from the equation, doesn't really impact the total mass statistics. So large spacecraft still represent the core business in space. They represent most of the revenues generated in the industry. And today, I don't see this changing in any significant way. So small spacecraft are not replacing large spacecraft. They are coming on top as an addition, as a new market segment and an activity which is being developed mostly today by commercial players. That may change slightly. We see that we have also growing institutional programs that will use smaller scale spacecraft and constellations. So we will touch about that when we discuss small spacecraft specifically. If you look at the figures here of small spacecraft at launch, again, on top you see the number of small spacecraft, and you see the acceleration in those numbers quite visible starting in 2012, 2013. But if you compare it to the mass of small spacecraft that is displayed at the bottom in the orange series, you see that this impression of acceleration in recent years was actually driven by two different trends which were annihilating each other. There were more small spacecraft launched in space, but those small spacecraft were increasingly small, so that in the end, if you look at the mass profile evolution between 2005 and 2018, basically you don't see any major change in the volume of activity, despite the fact that in the same period between 2005 and 2018, the number of small satellites launched was actually multiplied by more than 10. So clearly here, we see a first optical effect. We have small satellites being increasingly smaller and in larger volumes, but the total impact on the global space activity has not really changed. This, of course, if we don't consider Starlink, and if we look at the real acceleration of figures that are visible here in 2020 and 2021, both in numbers in the blue chart and in mass, in total mass in the orange chart, 90% of this impact is driven by Starlink and only Starlink. And then again, I insist a lot on that. There is really an optical effect on statistics, both in number and mass, because Starlink today is really changing the game in many, many, many different ways. So this is not what I call a general trend. It is today driven by one single player in the field. I saw one question popping up in the chat. I think it was Brice. Maybe you want to voice it now. I cannot access the chat here.
Yes, it was just to know if there is an available ratio between the amount of data which is, I don't know, communicated every day or something, compared to the active global mass of satellite.
Yes and no. Actually, this information is only available for some selected programs. It would be very interesting to have this idea, because it would give an idea in particular for the telecom programs, but not only, an idea of the global improvement of the service rendered by those satellites and the global efficiency which is achieved. However, I would like to stress one point. Technological evolution gives more power to the satellites. In particular in telecom, we see that now every telecommunication satellite has more bandwidth than the previous generation. On the other hand, and unsettlingly, the same technology trends are actually applying to the ground infrastructure. So when you look at the gap in terms of service offering between what is available from space and what is available from the ground, when you have overlapping markets and application, space is still usually one notch below the global availability of telecom bandwidth on ground. So the two markets are usually moving at the same pace, and we don't see at some point in time a major evolution that would actually change completely the economics of telecoms in space compared to the economics of telecoms on ground. So this is something which is a bit of a problem. But clearly we see the total bandwidth available from satellite growing and growing. This has been a major step when we have seen the introduction of high throughput satellites using Ka and Ku band and the broadband. So clearly this has really increased the availability of bandwidth in orbit from telecom satellites. But unfortunately, this global figure is not one I have ever seen on my side. If somebody has seen it and wants to share it, I would be very happy to have a look at it. We have it for some programs only.
Thank you, Pierre.
Speaking. I have some question. First of all, at the beginning, when you focus attention on the market, in order to clarify.
The connection is very, very bad. I hear that you are talking, but I cannot make what you are saying.
Are you able now to listen me? To hear me?
I hear you, but you shouldn't speak too loud and close to the microphone because it distorts a lot at my level. Thank you very much.
Okay, I will try. I don't know if now you are hear me in a better way, but my question was at the beginning, when you focus our attention for space economy on the market, I'd like to highlight that the space economy is more complex than only relevant to market evolution. And in particular, for what concerns the slide 5, where you trace all of the evolution, take into account the mass volume. Perhaps my feeling that we can trace better by taking into account investment instead of the mass, because the mass could interpret it in a different way by taking into account also the generation of Earth observation satellite during the period, and also take into account the number of satellite that for sure, not only Starlink, that is the maximum number of satellite for telecommunication, but all of the constellation that we have in this application are a huge number of satellite. So
you're moving
is only
to the presentation. These are the topics I will address later on. But indeed, yes, there are other ways to measure. Okay, so we will measure also, we will have a look at the investment in equity from the new space players. We will also have a look at those markets in terms of infrastructure which are expressed in value as well. And then there is also a point where we actually show what we can project about the future and the constellations indeed. So those are areas which are taken up a little bit later. So here I'm starting with the basics and then I'm moving towards more if you don't mind. So I'm making it, I'm trying to
okay, thank you very much.
To ramp up the effort. So yes, indeed, you're right. There are lots of other ways to measure. But again, one of the reasons why I like also the measure in number and in mass is because it's stable, so we can actually have a look at broad, large figures. And if you think about, I don't know, the automotive market, it would be interesting to know that if you look at what was the situation of the number of automobiles that was produced in the 50s and the number of automobiles which are produced today, well, probably the figure is multiplied by 10, if not even 20 or 100. What's specific in space is that if you look, for instance, at this chart, what we see, the number of large spacecraft produced, this is the orange chart at the bottom, you see that basically the number of spacecraft produced is not really growing. You see, if we take the market of airplanes, of course, the technology of airplanes is changing, the technology of automobiles is changing, but those are markets which are in growth. The number of units produced is growing together with economic growth worldwide. In space, this is not the case. The number of satellites, the mass of satellites deployed is not really growing, again, except the Starlink impact in recent years and the prospects we have with the constellations. So this is something which is really important to gather because it is quite specific. If you take any other type of appliance and infrastructure statistics, you will see that usually they have a growth profile which is matching the economic growth in general, not space. Space has been remarkably stable in past years. That is something which I wanted to insist upon. So now I'm back to those global statistics again, and they are presented again in mass on the top by spacecraft customer region. So we're looking at who is buying all those satellites. And at the bottom, you see the same statistics in mass, but looking at who is producing the satellites. And basically here, without going into the details, basically we should like to see two major trends when we look at regional dimensions here. The first is that China, which you can actually see in red at the bottom of our charts, China has been the growing space player in recent years. We also see that in the same period, the activity promoted by Russia, at the top it's the Russian customer in blue, has been decreasing and has been stabilizing in recent years. And then you see the importance of the USA. The US, in terms of volume, US customers are the #1 customers worldwide for satellite systems. And you can see Europe in orange, quite difficult to see, just on top of China. And you see basically that's the volume of business which is generated by European customers overall. But what is interesting is to compare the shape and color of the two slides, where you can actually see that the customer and the supplier usually come from the same region. This is another very important message that we repeat on and on and on. At the global level, most of the space activity worldwide is what we call localized, meaning that the customer and the supplier are usually located in the same place. 90% of space markets worldwide are domestically procured. Again, this is a very important message. And the other message from those two charts is the important growth of China in recent years. You see, China has been emerging as a major player. Here, again, we have figures in tons, and we can actually look at the global production output measured in satellites launched by the various regions. So on the left-hand side, you see the global spacecraft production by region in total tons. And on the right-hand side, you see the total mass launched based on the production region of the launcher. So if the launcher is Chinese, then we register the mass as China. If the launcher is made in Europe, then we register the mass as Europe here in orange. And here, if you look first at the spacecraft statistics, here again, you see very clearly the ramp up of China, where you see that Chinese production capability are now largely exceeding the European ones, the Russian ones, and are getting close to the US ones. And if they were not, and this is the other major signal that we have on this chart, if we didn't have the large volume of Starlinks which have been more produced and deployed in recent years, we would have a situation where the total output of the Chinese space sector actually exceeded the total output of the US space sector. So you see that we have a shifting range of ranking for the various space powers in the world, where we have now China being positioned clearly as at least the second-rate players. Then we have still Russia in blue here, which appears in third place, and Europe, which in terms of volume is probably in the fourth place. When you look at the right-hand side here, you see this is the mass deployed by launcher. And here it is interesting also to see the very big impact of the Starlink deployment on the total mass deployed by US launchers. You have noticed, as anybody else, that Falcon 9 has now become the most used launcher in the world, but also thanks to the fact that about 60% up to 70% sometimes of the total mass launched by Falcon 9 is associated to the deployment of the Starlink constellation, which is a very specific business area, insofar that this is self-funded by SpaceX. This is not an area where SpaceX is registering revenue for those launches. Another point is that here we see that the European launchers have actually dropped from third position in 2015 to the fourth in 2019. And in the meanwhile, again, we see that China has really stepped up its game and has now surpassed Russia in terms of global launch capacity. Okay? And here I start to introduce the first statistics in $1 million at purchasing power parities. Again, to do this, I will not go into the detail, but we use we do a parametric costing. So we take a lot of individual data points on the value of satellites, so that you can actually see on the left-hand side, this is the value of the spacecraft production market. And then we also have a look at the value and the pricing of the various launch systems worldwide. And when we miss a data point, we actually create an economic formula to generate a suitable data point that will be used to replace the missing information, so that we can every year make a wholesome assessment in $1 million at purchasing power parities of the various markets for space launch and for spacecraft manufacturing. So first, the big figures. With those estimates, the global spacecraft manufacturing market worldwide was in the order of $50, $54, $55 billion at PPP in the year. So this business is actually mostly associated or available to the US space sector in green and the Chinese space sector in red. What is very noticeable here is that the Starlink impact is differently than the assessment in tons, very, very small, because you have noticed that if we believe the declarations from SpaceX officials, the Starlink satellites are very, very cheap by the unit. So despite the large tonnage and number, well, even considering that the value which has been stated many, many times by Gwynne Shotwell or Elon Musk, even if we consider this is too optimistic, and this is what we do in our statistics, we step it up a little bit. But even that, it's a very small value in terms of business, because those satellites are so cheap. And this is where you actually see that in terms of global market available to the various segments, China and the USA are very much on the same layer. We see, again, the figures for the European market, which are below, very much below the market available to US and Chinese competitors, and which is sometimes a bit bigger than the market available for Russian competitors, which are really playing on another league. When you look at the global launch service market on the right side here, you see, of course, the same ranking. So the big are big and the small are small. We believe that the global launch service market worldwide is in the order of 10 billion a year. Again, here we see the Starlink impact, because we give a value to every Starlink launch, of course, using the market value of the Falcon 9 launcher, because we have to keep track also of that. But again, this is not a solvable demand, because the Falcon 9 is not being procured to actually launch the Starlink satellites. But you see here again the price impact of Falcon 9 being officially priced rather cheap. Of course, we would need to discuss whether or not everybody is paying for this cheap price for Falcon 9, which we know is not the case. And you see that when you put the actual market value for the launch systems, in our assessment, the global market available to the Chinese space players is actually larger than the one available to the US launchers. So here we see that Russia is still number 3 in the launch arena in 2021. In 2022, this will be changing a little bit, and probably in 2023, it will be dropping a bit more. We know that the Russian space sector is facing a lot of internal and external difficulties. So here, what we wanted to describe is that whether you look at it in value or in the volume, so in tons or in dollars, basically we have 2 space superpowers now, which are head-to-head. which is the US space sector, which is really driven by NASA, the DoD, and a lot of new commercial ventures. And then there is the Chinese space sector, which is in a catch-up phase, developing every single mission and application they can. And they also have a dimension of commercialization, because we see even in China some new players emerging from the private sector, and we also see the promotion of what look like consumer-driven applications in space from the Chinese. But as you will see, there's more to that. Now, another market segment that we like to develop at Eurospace is actually splitting the global space activities. So this is, again, the total mass of satellites launched every year. But we look at the type of customer, and we separate public customers. So this is where taxpayers' money is involved in buying the spacecraft system, and private customers. This is where, in the end, potentially there is a private market or a commercial, fully commercial venture, which can be used to support the development of the satellite infrastructure. And here again, I don't want to go repeating myself too much, but we see that commercial applications in space have really developed in the late 90s all the way to 2019. The business was rather stable with a few highs and lows, but you know, we never had any game-changing development in this arena. But since 2020 and starting of deployment of Starlink, which has actually deployed more than 500 tons now in 2 years, we see that the mass deployed on behalf of private players has actually really developed quite significantly. So this is really what I call the Starlink effect. If you remove that, there is nothing really new under the sun in space. Again, that's very important to notice. And again, I insist, the value of those Starlink satellites is rather small. So in terms of business opportunity, they don't change the overall market trends for space so far, again, in terms of total volume. If we make the same type of split and we look now at the value of those spacecraft produced and the value of the associated launch segment, we see that indeed the private space infrastructure, despite the large volume which has been deployed in space, but due to the fact that commercial satellites are usually less sophisticated and less expensive than the institutional ones, we still see that there is a ratio which is about 1 to 10 between the global value of the commercial-driven demand for space systems and the value of the institutional-driven demand for space systems. When you look at the launch segment, launch now is more commoditized, and there is still a difference in pricing between the launchers procured by institutions and the launchers procured or competed across the board for commercial players, so that in launch, the split between the value of commercial launch and the value of institutional launch is probably 1 to 5 and not 1 to 10. But we still see again here that the launch business driven by institutional demand is by far much more important than the launch business driven by private and commercial initiative. And clearly, this is a long-standing feature of space programs so far. And again, we will look at the prospects for constellations in the future, but I don't think that this will really change, because without uncovering too much what I want to say later on, but the commercial constellation business will only happen if those constellations can actually be launched on the cheap. So if everything remains expensive, this constellation market will not develop as expected. Then I will have a look at the institutional business, and this is an interesting point I wanted to make. We have here the institutional spacecraft demand. Again, one major message here. You see that looking at the global mass launched in space on behalf of institutional programs worldwide, we have a situation where China now is on a ramp-up phase, and it is well ahead of everyone. So We also see that in terms of volume of activity, despite the fact that the European institutional program is actually growing and the budget is slightly growing every year, but we see that in terms of volume of business in Europe, this is slightly decreasing in recent years. Here we see just the 2021 split of activity for institutional customers only. Again, same message, I don't want to repeat myself, but we see in blue the big importance of human space flight in both the USA, Russia, and China, which really represents a big volume of activity for the industry. Of course, we see that Europe, India, Japan, and all others are still very much underdeveloped compared to the others. Again, here, another look at institutional programs, and here we have a look at the global trend. So those are the military satellites launched by customer region, and we compare 2 decades of activity. On the left, the decade 2002 to 2011, and on the right, 2012 to 2021. And here really we see 2 major things. First is that space militarization is growing. The total mass deployed between the 2 decades for military spacecraft has increased by a factor 50%. So we have 50% more military space activities in a decade. Again, if you put that in the context of a rather flat volume of business, not growing, that means that the proportion of military satellite is actually growing. And we actually see that in the first decade, we had Russia and the USA more or less head-to-head. We know that the US really had a big technological advance over Russia, but they were trying to keep on a par. But here we see that in the last decade, the Americans have really stepped up their investment in military space, and we really see the catch-up from China, which is really deploying a lot of military capability in space in recent years. So this again is very important and clearly a point of worry for the global geopolitical balance in space. Then we get the counterpart here for the year 2021. This is the market for commercial satellites, so satellites procured by private entities. And here we see that again and again and again, when we look at the commercial side of the business, almost everything is related to telecommunications. Satellites, there is nothing much more than that in the commercial business. Now, of course, we also see a little bit of human-related activities. These are the space tourism kind of things that they are developing. Interestingly, we see, for instance, that now there's a supposedly commercial space station which is taking place. We're very happy to see that, for instance, Thales Alenia Space is participating to the development of the Axiom space station. So there are business opportunities which may arise from those markets, but today they are still very, very small and limited. Here is the evolution of those commercial markets. Again, those are the satellites procured by private customers. On the left-hand side, we have an assessment of the value of this commercial market, the launch value in a billion. And here we see the commercial spacecraft market by customer in tons. So you see the global evolution of the total mass launched. Again, we see that most of the growth in mass is driven by the Starlink program. Again, this is a very unique feat. And we see that this indeed has driven up a little bit the value, the launch market value, but we still believe that the global launch market for private and commercial satellites is well below the 3 billion mark. It's in the order of 2 to 2.5 billion a year. This is definitely a market in which the price competition is very strong. We assess the average value of the price to launch for this commercial segment, which is in the order of $10,000 per kilo. Of course, this average includes GEO and LEO, so 2 very different pricing and market realities, but then again, it's an average. And then again, if I look at the big message here for the evolution of the spacecraft produced for commercial segment, we see that most of that today, the growth is related to Starlink, which then leads me to say, I don't like it when I see people say there is a commercial space boom. I think this is a bit premature to say. Today we have definitely the Starlink impact, which is changing a lot of things in the global statistics, but it is not really what I would call a boom so far, because today the others, the computer competitors to Starlink, still have to deploy the same level of activity. And here, indeed, when we project in the past 20 years, the global value of the commercial demand for satellites, again, here they are presented by supplier. We see, of course, that most of the demand is actually benefiting US suppliers. You see that the blue histograms are much bigger than all the rest. We see that Europe has been and is still very well positioned to partake into the competition for commercial satellites, but we don't see this as a market in major growth. We estimate that the total value of commercial satellites in the past 20 years has been comprised between 3 and 4 to 5 billion every year. That's the value measured at launch. Again, that puts the global spacecraft value for commercial activities about 1/10 of the global value of the institutional programs. So you see, it is a very important market for the US industry, which has managed to penetrate this market consistently and to actually use it as a good complement to the value it made on institutional segment, but it remains a small, I would rather call it a niche market. One sub-segment of this market is the market for commercial satellite constellations. And what is interesting to notice is that, of course, this is a market which has regained in interest in recent years, as you can see here on the right-hand side of the slide. But what is interesting to note is that we had the first wave of satellite constellations in the late 90s. And what is interesting to notice is that actually 2 constellations made it through from the late 90s to the late 2010s here. So we see that the Iridium constellation has had consistently replenishment, as well as Global Star here. And we see that in recent years, we see a major step up of activities. And this major step up was driven by 2 new projects. One is Starlink, which is really, again, changing the shape of statistics. And the other one, of course, is OneWeb. In order to make a clearer vision of things, I have removed Starlink from the analysis. And so we can compare whether there is a major disruption. And what I would like to say here is that OneWeb, in terms of volume of activity and deployment, is not really disrupting what we have seen in the late 90s. I think that OneWeb is a second wave of constellation, which is really in the line, in the continuity of what we had before. And Starlink is really changing in terms of volume and approach. So I don't think that we should put every constellation in the same basket, because my approach here is that business models, market models, industrial models, when we look at OneWeb, Iridium, Global Star, we are very much in the same, I would say, legacy, whereas probably Starlink is a completely different and disrupting approach. So I thought it was interesting to actually show those 2 waves of constellation with and without Starlink, so that we can actually try and see what is really the trend and what is really the unique situation. So now that we have looked at the institutional business, we have looked at the commercial market segment, those evolutions. Again, the main point is that most of the market today is associated to institutional programs, whether you look at it in volume or in tons, whether you look at it in value or in $1 billion. Again, the global institutional demand is about 10 times above the global private commercial demand for space systems. This, of course, applies also for the launch activity. So here we have the split of the business the launch demand, which is split here between the supplier region. So here we see the total mass, the total mass is here on the right-hand side. The total mass launched by Chinese launcher and how much of that was driven by the domestic institutional demand. So this is the captive demand for Chinese launch services, and how much of that was actually devoted to serving commercial and private and expert customers. So we see that for China, most of the market is actually driven in terms of tons by the institutional government programs. And when you look at the segmentation in value that we have here on the left, we have more or less the same trend. In Europe, here we see that the European launchers today have been very much exposed, and here it's accumulated statistic for the 5 past years, have been very much exposed to commercial and expert demand, where the domestic institutional demand has been very small, either here in tons, either here in value. And here you see the difference in pricing between the launch segment for institutions, which is slightly more valuable and expensive. And here we see the pricing for commercial and competitive launch, which drives a little bit less value than the equivalent in tonnage. And I will skip India and Japan, whose launch activity is quite small and very much driven quite exclusively, at least in the past 5 years, with the domestic institutional market. With the recent one when launched by an India launcher, of course, we would see a bit more here in the blue, but we should see whether or not India decides to develop a lot this business segment. What is interesting to notice here is that Russia, like China, is very much driven almost exclusively by domestic institutional demand for its launch activity, which is about 3 times the value, the volume of its commercial and experts demand. And this is more or less the same ratio you will see on the left-hand side in value. And what is most striking here is the difference in the 2 histograms for the USA. You see the tonnage of mass deployed, and again, the huge impact of the Starlink satellites, which appear here in the blue histogram. Okay, so in total volume of activity, today, the private commercial initiative, or Starlink, is actually outperforming significantly the total mass launched on behalf of domestic programs. But when you look at the pricing and the value of those market segments, you see that even in the USA, like in China, like in Russia, most of the value generated by the launch service segment is associated to the actual domestic institutional demand, which is paying much more for the same type of service than the commercial market. So this is a very important point to make. Globally, the captive institutional business is always more attractive than the commercial one, both in volumes of demand and both in the value generated for this volume of demand. So this also is something which is counterintuitive today, but it's very important to notice. Today, developing a launcher specifically for the commercial business segment is actually much more difficult, because this is where you have the highest tension on prices and competitiveness. And so this is something which probably your institutions need to understand. The existence of a viable domestic institutional demand is, we repeat it all the time, one of the essential features of the launch market. Here we see the same charts, but looking at global spacecraft production. Again, on the left-hand side, you have it measured in $1 million at purchasing power parity, okay? And then on the right-hand side, you see the volume of production measured in mass in tons. And I will not go through the full description, but you can see here exactly the same analytical points as we had on the launcher business. We have only in Europe a volume of business for the commercial and expert market, which is actually slightly bigger than the domestic institutional one. For all other space power, the domestic institutional demand provides much larger business opportunities than the commercial and expert markets. And we see, again, for the USA, this very bizarre inversion of a ratio between the mass of satellites launched on behalf of domestic institutional markets in gray, and on behalf of the commercial market, which is mostly Starlink in blue, and here the actual value of those business segments, where you can actually see that the total assumed value of the Starlink deployment is super, super small compared to the total business associated to the institutional domestic market. So this is the end of the general trends and introduction I wanted to make. Maybe I can open the floor a little bit for questions or comments or discussion before we actually move to what I call the discussion and controversial topics. So the floor is open. I will stop sharing for a while so we can see the faces. So you can put your camera on when you raise a question. It's nice for me to see your face as well. So please, Brice, your hand is raised.
Yes, I had a question. Maybe I missed a point. It's about the fact that you can do much more today with 1 kilogram of satellite compared to 1 kilogram in the 60s. I don't know if you have a value or if there is one way to compare. I mean, we know we have the I can't remember the name, the law for increasing the CPU
The Moore
power,
law.
the Moore law.
Yes.
I don't know if you can normalize your figures with such a consideration.
No, we cannot. One figure I saw in the past, we were looking at the global throughput of transponders, okay, for geo-telecom satellites, so a very specific segment. And I had seen a report, but it was a few years ago, that was measuring the total throughput improvement thanks to the digitalization of those satellites. So moving to the digital transponder after the analog transponder, which eventually now also gives us the possibility, you know, to usually to make a frequency chopping so that we can actually serve more markets. The global improvement in throughput was a factor 37. So the total throughput available for a satellite was 37 in a decade, moving from the analog to the digital. That was an Euroconsult report on total bandwidth and throughput. So clearly, this is improving a lot. But what is interesting to note, and at the beginning of the presentation, I was mentioning this, every technology-driven segment has benefited from the Moore effect in the same way. So if you look at the first generation of GSM telephones, basically we had 8 kilohertz total bandwidth available for each call when we only had voice. And you know, sending text messages was a secondary part of the network, and they would only go through if the network was not in load. When you look what we have today with 5G, we have really grown that a lot. But what is interesting is to see the spread of handheld devices. And this is one of the points I wanted to make. I don't have the statistics at hand, but they're easy to find. The number of telephones and the number of cell towers has been increasingly consistently in the past 20 years. So that today we have much more cell phones, much more cell towers. During the same period, the technology and the bandwidth available on the phones and on the towers has also increased tenfold thanks to the Moore law. So the total bandwidth used by cell phones is actually growing even more. On the other hand, during the same period, we have not seen the same growth in satellite infrastructure. This is the point I wanted to make, is that technology improvement actually keeps the satellite business afloat with more tech, more bandwidth, more capacity available, but it is not driving growth so far, unless this new wave of constellation is unfolding and developing as we do expect. But you see the point I wanted to make, because it's pretty surprising if you think about it. You know, you would expect that indeed, because the satellites are much more capable today, then people would use them even more, like we do for everything which is telecom infrastructure on Earth. This has not been the case so far. Again, the new major change could be the constellation, but we should always keep in mind that every technology available for telecom satellites is also available for ground infrastructure at the same time. So the level of competition remains more or less the same.
I had a small other part, which is how can we consider the ground segment part of your analysis? I mean, we are involved as Safran in the ground segment, and I would be very interested in having some kind of mirror effect. And you were just talking about the this infrastructure for the telecommunication and ground telecommunication. I'm talking about the ground to space connection.
So this is one area where it's very difficult to find the figures and statistics. I think that it's completely overlooked. Today we know that whenever you have a satellite infrastructure, if it has to be used as a commercial system, it needs to branch up with the global telecom networks on Earth. So basically you need gateways. The gateway market is one for which, personally speaking, I haven't seen a lot of open source information. We know that there are a few reports. One thing which is clear today, and this is one of my main assumptions, is that this gateway market will be dimensioning the actual commercial offering for future commercial systems. And when you look, for instance, at the Starlink deployment, you look at the OneWeb deployment, the service is only available so long as there is a local gateway which is available. ISLs, of course, are giving more flexibility in the use of gateways because you can actually transfer data directly between the satellites until you need to land down on a gateway. However, they don't remove the need for gateways unless you have a self-sustained service which is only using terminals, so that it's a closed loop system which is not interacting with the global network infrastructure. But as long as your satellite infrastructure is a part of the global telecom infrastructure, then of course the gateway is a dimensioning factor. And here I believe that optical gateways are the future. I think that RF gateways will soon find their limits in terms of available frequency, especially since we have a lot of commercial constellations which are seeking deployment and everybody's fighting for the same frequency for the user link. So in the end, going optical for those gateways will improve the global capacity of the network deployed in space. So I think this is a major trend. I regret that we don't have enough figures for those gateways, and we do a lot of market watch on the satellite deployment because it's a visible point, so we know how to measure that. Mm-hmm. And regretfully, all those gateways are localized, they're associated to local regulations, so you need to apply for frequencies. So it's a very complex business point, and it's one potentially with a lot of revenue associated because it's high complexity, lots of data rates. And US observation infrastructure will also use those gateways. So it's an area where basically you have a lot of synergy because dropping the data down is more or less the same problem for telecom service and for Earth observation services. So again, it's a major area of development. But regretfully, I don't have the figures. I know that Euroconsult and NSR, they regularly produce those market studies on gateways. And you know that Eurospace, we don't have the budget to buy those studies. But if anybody has a clue, maybe we can actually exchange a little bit.
Okay, thanks. Thanks very much.
So we have the question. I don't know what's the order. I'd say ladies first, Anna Maria.
Thanks, Pierre. First of all, thanks for a very interesting presentation and analysis. My comment, and I have found at the end the answer to my first question. But anyway, I think that there is what you have mentioned, the Starlink effect that will condition all the analysis and trends, I think that could be better if you can have in the future a split on your analysis, take into account the major three, telecommunication, Earth observation, and human exploration, because the market and also investment of the country is totally different. The motivation and also the analysis, by taking into account, as I said before, by taking into account also an analysis against the mass and volume is totally different if you speak about telecommunication and if you speak about the Earth observation, because anyway, the number is sensitive, is totally different. With Starlink, we speak about 3,000, but also for other telecommunication constellation, we have 1,600 and so on. There are a lot of initiatives that are going on. Instead, for Earth observation, you have a totally different number. You can have 30, 40 as a maximum, but not more. And also by taking into account the question of Bryce for the ground segment, also for the ground segment, the evolution is totally different because it's growing a market for the terminals, for the telecommunication, but for the ground segment of Earth observation, the situation is a little bit different because it's more in relation to the acquisition station for what concerns the link, but there is a total reviewing in terms of concept of the ground segment. So this is only my comments was only to contribute in the global picture what can be better highlighted by taking into account a split. What do you think about?
No, well, you're perfectly right. And if in our statistic, we usually discriminate correctly between the various type of applications. So I have shared the trends. If you remember, that was one of the first slides I was showing, so that we could see our Earth observation activity has gone down due to the fact that basically we moved from an analog satellite, which was really, especially in the Russian time, but only also in the USA where they did that, to fully digital sensors and digital data links, which had actually increased a lot the value added created in space with the same infrastructure. So we will see later on, because there is one little chapter here on mega constellation, the split between Earth observation constellations and telecom ones, and we will see how this is also impacting the figures globally. But you are perfectly right. There are two very different types of business. On the other hand, what I would really very much like to insist upon is that today, Earth observation is still driven, I would say 99%, by institutional demand. There are a few things emerging on the commercial side, but they're still very, very limited in terms of importance. On the other hand, we see that the telecommunications segment seems to be now driven mostly by private and commercial demand. So this is where there is indeed a very big difference between the two. So we keep an eye on that. And again, talking about this ground segment approach, I think this is an overlooked area, but also because it's difficult to track. So we will see what we can do to improve this on our side, but regretfully, we have to rely on data availability. So we
thanks. I totally share that Earth observation is mainly driven from institutional, what we can see in terms of facts. But anyway, we assist also to a discrepancy between what is desirable, because they continue to insist on the private sector and investment in the PPP with another means as a public-private partnership. And instead, at the end, the real model that is functioning in order to go on in terms of technology and also to grow our presence in Earth observation, it will remain the institution.
Oh, no, you're absolutely right. We have another hand raised here. It's Didier. Didier Morancet?
Yes, good morning, Pierre and all, and thank you for the very interesting presentation.
Not
I
finished.
had a question on the trend, one of the slides you presented on the trend of the institutional spacecraft demand.
Yes.
And in Europe, you showed a quite significant decrease in the last decade. I was a bit surprised by that because in the last decades there have been the space budget from the EU. You have a number of national projects as well, so I would have expected at least stable or even a small increase. So maybe if you could comment and elaborate on this
Yes,
trend that you have analyzed.
absolutely. So basically, we have in a situation of cognitive dissonance. So you are right, and we have tracked this as well. We did a little webinar a few months ago on the evolution of European space budgets. The European money available to fund space programs is growing. The fact is that all the money is not going to actually deploying satellite infrastructure. As you very well know, a lot of the money is also spent on preparatory activities, which do not register in the volume of spacecraft launched, which I'm actually showing in the figures, and which by consequence do not register in the value of the business of those spacecraft launched. You see the point I am making. So here, clearly, we see that those growing budgets in the European space sector have actually been associated to a lower volume of launch activity. And this will again start growing when we have the new Copernicus, which are actually been launched, and a few other programs which have been emblematic. But today, again, making the difference between the volume available for your business in preparatory studies, R&D, launcher consolidation activities, etc., which is actually growing, is also associated to a trend which in volume is of less satellites being launched in recent years. You see, so, but you're right, the business is growing, but the volume of activity is not really growing in recent years. This
So
is
if I understand
this
you,
optical effect.
yeah, thank you very much for the explanation. If I understand you correctly, so you should see this effect of the growing budget in the coming years, and so there should be a kind of if we make a forecast, there should be a further increase, not huge as China, but at least a further increase.
Absolutely, there should be a little bit of an increase. I must also say that since Europe has decided to stop the ATV program, which was a big chunk, of activity, that was producing a big impact in terms of volume in the statistics. Of course, this is also contributing to the optical effect of reduction. And the larger the satellites, the more you see it when you count it in tons. Okay, if we do more expensive, smaller satellites, and one of the examples I like to use is the European Galileo satellite is about 700 kilograms. You see, the equivalent, the US GPS satellite is about 3.6 tons. So clearly, again, there is a volume effect. That doesn't mean that those Galileo satellites are not super interesting in terms of business, that they're quite expensive and they're associated to a lot of R&D and research. So sometimes those volume statistics can be slightly misleading. So it's important indeed to be able to share them with you and to discuss the limits of those figures, although they are useful and easy to compile, but there are limits.
Okay, thanks a lot. Thank you very much.
So, other questions, or shall we move to the other subjects? Well, so I will start the other part of the presentation, the one which is associated to what I call controversial points. So let me open it up again, as I had closed it. Okay. So there we go. Now open. Voila. So the idea now is to have a look at a few other subjects which are really worthy a discussion. Again, I will share those things, and the idea is to be able to discuss with you how you feel about them. And so the first one I wanted to share with you was the point on world space budgets. Can you actually see my screen again? Yes,
Yes, it's not
can
in.
I
Yes.
full screen now?
It's not in. Yes.
Now it's in full screen. So
Okay, perfect.
thank you very much. So one of the first points I wanted to share with you is the problem of measuring the world space budget. So this is a policy or political measure, which is quite important because it's used to actually measure the distance between space powers. And more than often, we are treated to this kind of analysis, which you pretty well know. On the left here, you see the Euroconsult figure, which is actually sold quite expensively in a report, which is published every year. And then it is tweeted everywhere. But here we see a very similar assessment, which is actually the one provided by the Space Report. And I believe to do this, they subcontract the activity to Bryce. So those figures.
Not to me, huh? Not to me.
No, not
No,
Brice.
I'm not in this
Right.
business.
Yes. So basically, you see that they come more or less to the same value, 92 billion for 2021 here for Euroconsult. Here we have the figure for 2018. Why not? And it's 85 billion. So the order of magnitude is more or less the same. And if you look at the split, it is usually more or less the same, where basically the impression they are giving in that half of the global spending on government programs worldwide is actually the USA. And you see here we have exactly the same in Euroconsult, the same optical impression. 54 billion is the USA and China only represents 10. So the problem with those figures is not that they are incorrect. Basically, if you look at the blue ball here, the US, then if you look at all the red bubbles here, which is Europe, all those usually are pretty well documented and sourced because we have publications, official publications on space budgets in the USA, which is super transparent. To a lesser extent in Europe, we have a lot of data available on European space budgets. And then if you look at the other small data points here, Turkey, Egypt, Nigeria, Argentina, all those are usually pretty well known, including India and Japan. But when you look at these other two bubbles here, Russia and China, I must insist, and I've been insisting on that many, many times already, there is no official data source. So those two data points are literally inventions. They are made up by the consultancies. There is no basis in which we can actually say why we have 10 billion here. And Euroconsult doesn't really explain how they are doing it. Similarly here, when I look at the total split, I'm looking for China. China is shown here in the Space Report data as representing only 10% of the global space institutional spending worldwide. I mean, I am sorry, but considering that this figure is an invention, why do they decided to make it so small? It doesn't really make a lot of sense. I think that for the sake of transparency, those charts should say China, no data available. Russia, no data available. And in fact, again, if I want to show you, this is my assessment of the institutional spacecraft market value by supplier region in tons on the right and in $1 million on the left. And here is the total impact of institutional programs in the world. And clearly my assessment is that China in value and in volume is really matching the United States. There is no political logic in producing a figure in which China is just 1/5 of the total spending of the USA. There is no value, but if they need to invent a value, I would rather see a value that looks like this in those histograms, because I believe it truly reflects the actual impact of global government spending worldwide. And again, I'm showing this slide for the second time, but we are seeing the ramp up of China, which is not captured by the charts presented by Euroconsult or NSR or Bryce Space or the Space Report about government space spending. So this, I believe, is a major shortcoming of analytical data today, is that looking at European space budgets, the main players do not say, we don't know, and rather they invent a figure. The reason why they decided to make it so small remains a mystery to me. I don't know if there is any discussion point we want to make on those space budgets. Hand raised, no hands raised.
Frankly speaking, I totally share with your analysis. Is the doubts that I have every time I analyze their consult survey.
Yes, again, the sound was not very good, but you say that you are sharing the point, right?
Yes.
Thank you very much. And I see that Brice is also raising his hand.
No, keep on going.
Okay. So the other point I wanted to share with you, maybe with a different take, is the small satellite trends. So small satellite trends have been a hot topic in the past almost 10 years, but really in acceleration for the past 5 years. Those small satellite trends have actually even driven the development of a number of new launch players. And so this is why I believe it is important to have a look. So here I wanted to share with you one first chart, which I made myself. So I try to keep track of every single constellation which is presented in the press. And the idea is that in this chart, you see the total number of satellites for each of those constellations. So you see the biggest one now is the Starlink V-band, okay, which will reach maybe 12,000 satellites. We have the Chinese Guowang constellation, which is about the same size. We have Amazon Project Kuiper, which has announced plans for up to 3,000 satellites. So beware, this is a logarithmic scale. I am in front of a scientifically educated community. So at every step, we multiply by 10 the number of satellites. Okay, so this is a very interesting thing to show things which are highly spread on a big distribution. So you see that we have so many constellations. Today, I have numbered 226 constellations worldwide, which are proposing to deploy more than 52,000 satellites. Okay, if I only look at the projects which have published funding, so they have secured some amount of funding to deploy their satellites, there is only 156. They represent 37 satellites to be launched in the next decade. And then we look at the total number of satellites actually deployed by those constellations. There, of course, we scale it back to a major difference, because out of those 37,000 satellites for the funded constellation, basically only 10% have been deployed so far. So this is the first analytical points. There is a lot of PowerPoint proposals to make and deploy a lot of satellites in the future, but so far only 10% of those plans have actually been unfolded. Today, satellite mega constellations, they are probably the main driver for what people believe could be a transformational growth for space applications in the next decade. So if we look at the impact of Starlink on statistics, and then we project a similar impact for constellations such as Guowang, the Project Kuiper for Amazon, the Telesat Lightspeed, etc., etc., we probably see that if those constellations appear, then they will change the nature of space activities, and that would be a paradigm shift. Most of this demand in the future is driven by broadband application. And the institutional demand, interestingly, is still a little bit below what we see from the commercial developments. So this is also something which is transformational. As I showed you, in the past, institutional business was driving growth for space activity. Now, with the rollout of those mega constellations, we are seeing a paradigm shift where if there is a major point of growth, it will come from commercial application, commercial and private developed space infrastructure in the form of constellations. Let's have a different look. Here we see the main projects. So this list is not mine. It comes from Doug Messier from Parabolic Arc. But you see the number of satellites which have been planned by those well-known constellations, Guowang, Starlink, Kuiper, OneWeb, Lightspeed, Spire. There is also a V-band project from Boeing. So you see about 30,000 satellites just for 7 projects here. And then we have also a lot of new applications which are coming up with even larger numbers. This list is a bit old, so we don't even see here the infamous E-Space constellation of more than 300,000 satellites, whatever that means. But what is interesting here on the right is that if we compile all the projects from the previous slide, and we look at the total mass by multiplying the number of satellites, which the planned mass of each satellite, we see that only a very small amount of mass has already been launched. And we also see that most of the demand, if we look at the total mass to be deployed, comes from global communication systems. Again, broadband is driving the transformational moment. We see that if we compile all the data, and there are quite a lot, and if we think about Capella Space, ICE-I, Umbra, and whatever, we see a lot of remote sensing constellations which are being proposed, Aurora Tech. I mean, there's so many, but even compiling them all, remote sensing will not transform the total demand for spacecraft infrastructure in the future. It will be an add-on, but it will not be a transformational moment. This transformational moment will happen with the communications infrastructure. Again, this is something which is very important to understand, because those are two completely different business models in the end. Okay? And again, I insist a lot on that. Without commercial communication, you don't have this transformational moment. So what are the projections we usually see with this respect? This one you probably saw, it's from a year ago now. It's Euroconsult projection for a small satellite at launch. So they define small satellites as satellites below 500 kilograms. And you see here, this is the statistics in number, and you see the very big growth, okay, of demand in 2020. And what is not stated here is that 95% of this red growth here that you see is actually only Starlink. It's not, I don't know what are the constellations, a lot of projects, it's only Starlink. And then we see the projected growth for other satellites. But here you see that since this is the statistics in number of satellites, they don't discriminate between the Planet doves, which are about 10 kilo each, the OneWebs and the Starlinks. It's everything piled up. So I believe that this is not giving us a very good information. Another figure which you may have seen already also is the projection from NSR, Northern Sky Research, which is a competing firm with Euroconsult. They do more or less exactly the same work. Here just is a split between demand areas. So you see North America today is driving most of the demand. Again, what is not put on this chart is that most of the demand you see here is basically Starlink. So if you remove Starlink, those two charts have completely different faces. So since I have this big constellation information in an Excel file, I've also created a rough constellation demand model, which is ramping up. And here you see in total mass what this demand could represent. Okay, this is the probabilistic model. So I am taking all the constellation, and depending on how well they are funded and how well the system is defined, I put a probability base. So this is a potential profile of demand in the next years, driven by the global constellations. And here you see that most of the mass is actually driven by communication systems. And if I put this in number, this is what we should do if we want to be able to see also the Earth observation business. But again, most of the demand, the value, the launch demand, etc., is driven by broadband commercial constellation. So This is very important because this broadband commercial model, which is driving all the expectations for the next decade for growth in business for satellite, today it is still unproven from the commercial point of view. Even Musk says that Starlink Generation 1 is a financial challenge. Those are his words. And it's supposedly the best in class. So today, if those constellations cannot prove that they can be viable, so that they can deploy, operate, make profit to fund the next generation and keep operations, if this business model is not validated, I can say that these projections, they will never happen. There will be business associated to deploying the proof of concepts, the prototypes, and maybe even the first generation. But if this business doesn't break even, if it's not good profit, then it will not come back. And if you remember, I was showing you the first waves of satellite constellations. In the late 90s, we had a lot of flurry and excitation about Globalstar, Iridium, but also Skybridge and Teledesic and all the others. And there was a big bubble like the one we have today. Two managed to deploy in full scale, and they had a very difficult financial history. And only two survive all the way to now. I'm not saying that this will be the roadmap for all the others, but everybody knows that this is a challenging business case. So I insist a lot on that. This business is only viable if those companies manage to make and secure a good business with the broadband application. And we know that this is difficult. So if this is not a break-even, then those projections are meaningless. They will not happen. And this is something which I believe should be recognized more, because it's a one single showstopper for all those projections in the future. So now let's have a look at the past. You know, I like looking at the past and seeing how much of those small satellites they've actually managed to create business for the launch market, for the satellite manufacturers. And here I give you detailed statistics of what has happened in the past. So here we see two charts in numbers and in mass. It's interesting to compare them both, because there is a lot which has been said about those very small satellites, such as the Doves from Planet or the Lemurs from Spire. Actually, a few years back, everybody was talking about the small satellite revolution, because these guys were launching literally hundreds and hundreds of satellites. So when we look at the total number, indeed, we have seen a ramp up for those light blue, very small satellite constellations in the past, and actually they're still launching. So these guys have launched hundreds of satellites in recent years. The fact is that those satellites are so small and rather cheap, is that if you bundle them all together, you could actually deploy almost every single satellite launched by Planet and Spire in the past 10 years with one single Vega launcher. So you see, it's an interesting point of business, because they're deploying a lot of satellites. So they're changing the paradigm, but still, from the global economic perspective, what they do is completely irrelevant. In other terms, they don't even appear in the mass statistics. If you see them on the right, the blue histograms are completely invisible. That's because, again, the total business associated to satellites below 100 kilograms is almost irrelevant at the macroeconomic level. It means also that they will not generate big business opportunity, neither for the launch community, neither for the satellite community, the satellite manufacturing community. Here we see, when you look at the total tonnage, that the business opportunity are actually given by satellites which are bigger than 100 kilograms. Actually, the only histogram you start seeing are the green ones, where you have the general minisat category, then you have the OneWebs, which have actually really stepped up the volume of activity in recent years, and then, of course, again, the Starlink impact. So you see, this is what I insist a lot. If you look, again, only at the data in numbers as presented by the Euroconsult chart here or by the NSR chart here, you are not looking at business opportunity. because the business opportunity, they're more related to the volume. And this is what you see on the slide in tons. So again, since we have an economic model, we can also transform this volume of activity into market estimates. And here, we believe that the global launch market value for satellites below 1 ton, and you see that in green, you see the category of satellite below 500 kilograms, and then in red, we see the other important market, which I wanted to put here because it's for bigger satellites, such as the Telesat Lightspeed, which will be coming up, but this is also the category for Iridium, for instance. We see that in terms of launch business, small satellites below 1 ton, or small satellites below 500 kilograms, if you want to go to a more limiting factor, they represented overall a business which is in the order of 1 billion a year up to 1.5 billion in terms of launch demand. This is because the deep green part here, the Starlink deployment, is not associated to an actual launch demand because they are launched directly by SpaceX at their own cost. So the launch business associated to small satellites in the past has been quite small. If we push the limit all the way to 1 ton, it was in the order of 1 to 2 and now even 3 billion euro a year. And if we limit that to the market to deploy satellites below 500 kilograms, it is maxed at $1 billion up to 1.5 billion in 2021 if we don't count into the Starlink effect. So this business is about 1/10 or 10% of the total launch business. And it was already the case almost 10 years ago. It was a bit less, but it was still there. If you look at the value of building those satellites, again, we have the same impact. The total business of building small satellites for constellations in the institutional and in the private market is about 1/10 up to 1/5 of the total business of satellite manufacturing. Remember, we made this estimate of $54 billion, the total spacecraft manufacturing business in 2021. And we see here that in 2021, about 8 billion was associated to satellites less than 1 ton and about 6 billion to satellites less than 500 kilograms. So you see, it is a fraction of the market, definitely not the main one, and one which is representative of an interesting value point. On the other hand, I insist, when you look at satellites below 100 kilograms, the market value is super small. And when you consider the lower end of the spectrum, the satellites less than 10 kilograms, so starting with the blue histograms here, this is how you realize that the market opportunities offered by those very small constellation of very small satellites are not very interesting in terms of market points. If you want to make a business with these guys, it will be a low volume, low value business, even if you capture it all. So I don't see this as, again, a transformational moment. I saw a question pop up quickly in the chat. Maybe the person who asked it could actually speak it up. Thank you.
Yes, Pierre. Sorry, I have some troubles today with the connection, but just wondering something concerning the previous slide where you mentioned about the profitability or the break-even point for the telecom satellites.
Yes, the broadband.
I was wondering if you have any trends or any proof that remote sensing constellations are already or are going to pay off soon.
Well, actually, no. Regretfully, even for Earth observation, the information we get is that it's very difficult to break even. So today, basically, you have two major actors. Okay, one in Europe, it's Airbus GIS. The other one in the USA, well, USA and Canada, it's Maxar. So those are the two big private operators which have their own satellite infrastructure. Both of these players actually rely a lot on public demand for their data set added value, etc. And today you have a few private players which are now floated on the market. So you can have a look at the financials for Planet. You can have a look at the financial for Spire. Similarly, we have Black Sky, Satellogic, and a few other companies which are new emerging players on this segment of trying to develop on private funds a viable market model for Earth observation satellites. There is ISI, which I forgot to mention. All those now have almost public accounts, and all those are not mature yet. So it's difficult to say that they will not make it. But for the time being, they still have costs which are exceeding revenues in a significant way. So basically, if you take the example of Planet, they have a total business which is in the order of $100 million. I'm talking from the top of my mind, but we can get the detailed figures later on. And they have losses of about $50 million out of those 100 million. So they have difficulties improving their business model so far. It is very difficult to find customers for data and value added on remote sensing. And if we look at the business model of Maxar and Airbus, the commercial customers are not yet emerging. If we take the example of the figures collected by the European Association of Remote Sensing Companies every year, they produce a study on the revenues. Most of the revenues are still driven by public business. So it is very difficult to say what would be the future of that business case. On the other hand, my impression is that it is potentially easier to break even on Earth observation rather than on broadband, because on broadband, every customer costs you in capacity. While in Earth observation, in theory, you can sell the same bit of data to more customers. So the difficulty is attracting more customers to the data set and the service, but that will not increase your cost of operations. On the other hand, for LEO broadband and IoT, the total capacity deployed is actually a dimensioning factor for the total revenue. So if you want to attract more customers, you need to have more capacity. So CapEx grows when the market grows. In Earth observation, you can have stable CapEx and market growth. So from the fundamentals of the economic model, I believe that the Earth observation model is slightly less risky than the broadband or IoT model. Do we have other questions? So I don't see more. So here I have a summary slide on the LEO constellation. I don't want to go through everything in this one also, but I want to highlight one very important point. Again, most of this constellation business is for telecom. And basically, it's all about broadband. So broadband today is the #1 telecom service worldwide, and it is associated to major investment in ground infrastructure, cable, fiber, and cell towers to roll out 4G and 5G infrastructure in the world. And when you compare the global investment that is made on Earth and the return on investment which is expected, clearly my impression here is that the CapEx associated to the LEO constellation broadband deployment is too high in front of the potential revenue that it can generate. So this can be the subject of another long discussion by itself, but my impression is that today the cost of satellite infrastructure is still too high with regard of the total service which is available via satellite. So if satellite broadband infrastructure is there to complement and compete with commercial broadband infrastructure, regretfully, it will probably lose. It will only be able to win on those very specific niche markets. So we talk about in-flight connectivity, but it's a very small market. We talk about maritime connectivity, but it's a small market. We talk about government customers, but it's a small market. Other than those small markets, I think that the massification of this application service will be a tough point due to the inherent cost of deployment of this infrastructure. Without further ado, I would like to move to the next subject, which is about the new space. So we know that this is a subject which has been talked a lot in the past and which is still a subject of interest and analysis. So you may not know, or you may know, that at Eurospace we keep track of every new emerging space player that we can see in the press, in the news, on LinkedIn, in Twitter, and so on. And everything is compiled, so we try to keep track for each company of how much funding they have been able to raise and how many employees they have hired so far. Actually, this employment indicator, we are the only ones making it. And of course, we count the companies by creation date. So on this chart, you actually see two of those indicators. In green, you see the number of companies created every year. And in blue, you see the total equity raised by the company accumulated at the year of creation. So you see the total equity raised. I think that this was not updated correctly. It's not a problem, but it's here the total equity raised in 2000. So this is the money raised by Blue Origin specifically. And you have here the big lump in 2002. 2002 is the creation year of SpaceX. And so we accumulate all, I know this is the employment, not the equity, sorry. In blue, it's the employment. And so we have more or less 3,500 employees in Blue Origin, so they're accumulated here. We have now a bit more than 8,000 employees for SpaceX here. Actually now, some figures say there is even 12,000 employees in SpaceX. It's very difficult to know because there's no official statistics. So for the time being, I have a conservative figure here. And we see also a few other values for the accumulated employment, okay? What is interesting is to look at the company creation rate, and you see that there has been a big growth starting in 2010, 11, and 12, and then it's been accelerating all the way to 2018. But then we see that company creation is decreasing quite fast. So this is probably what people call a hype cycle, and we may be we have passed what they call the peak of inflated expectations. So everybody was excited about new space ventures, and they were attracting a lot of interest and investment and so on. But probably now, people are moving towards more prudence and giving more attention to the fundamentals of the market. So we may see a decrease in the figure of company creation. So the total number of companies we have in this chart is about 800 companies. They only reflect company in the upstream and the midstream, so the business of building and operating launchers and spacecraft. Okay, and we have today already 31 companies which have gone bankrupt in the period, which represent 400 employees and about $600 million of equity raised in the past. When I move to the next slide, here I will be able to show you the total equity raised. And then we segment it by region so that the color is giving you the origin of the company. So in blue, we see the Western Europe companies. And of course, in brown here, American, US companies. And here clearly we see two main things, is that for some reason, most of the funds have been raised by transportation companies. I'm saying for some reason, because if you remember my previous charts, the market for space transport is the smaller segment of the total space market. Actually, most of the business is associated to a satellite production and not launchers. On the other hand, investors have really favored here launch activity in terms of equity raised, so that today, out of the total 40 billion which have been invested in new space venture by private equity and venture capital funds, actually more than one third was associated to space transportation. And then Constellation have actually attracted a lot of funding, but as you can see, it's very small funding compared to the total available for transport. So clearly here we see a very unexpected indicator of what investors have understood of space markets so far and where they believe most of the value would be in transport. Of course, this figure is obfuscated by the fact that if you take this total figure of 19 billion, which has been invested in global launch, new launch ventures worldwide in the past 10 years, well, 15 billion of those 19 billion were actually only with SpaceX and Blue Origin. So clearly it's two players which are absorbing most of the funds. And this Pareto effect is very visible across all the slides. Okay, whereas we see that most of the budget, most of the employment, most of the economic value is actually absorbed and created by just 3 companies worldwide. Again, SpaceX, Blue Origin, and OneWeb have created most of the business associated to those new space ventures. All the others are 1 or 2 orders of magnitude below in terms of total value created, total equity raised, or total employment. Here we see the same chart, and we see again that basically employment figures are actually matching the total budget available. So we see that here in the constellation business, I separate Starlink with the launch business of SpaceX, but we see here that most of the employment is today in the transportation segment, consistent with the fact that this is where most of the money is available. And then we have also here a lot of employment opportunities associated to the Starlink, but also now the growing Kuiper project. In total, we estimate that in the upstream and the midstream business, there are about 38,000 or maybe 40,000 new employees. So those are new jobs created by those new space ventures. But then again, I insist a lot on that, more than half can be found in 3 large companies worldwide, and all the rest is very much spread against a number of companies which are all small scale players compared to the 3 big. Here we have an overview of the situation in Europe, where you can actually see the funds raised and the employment value. So we estimate that the total fund raised by European new space players in the past has been in the order of 6.7 billion. They represent a total of almost 6,000 new space jobs, which have been created in Europe, which is actually quite a lot. It's a 10% growth in the past 5 years, which has been driven exclusively by those new space employment opportunities created by new space ventures in Europe. And I have a list of almost 300 companies created since 1991. And here we see that in Europe, the focus is more on spacecraft manufacturing activities. Of course, the midstream, due to the OneWeb impact that you can actually see very big here. But most of the capacity and the new employment in Europe is driven by spacecraft business more than transportation business, which is a more balanced approach, which I believe is more sensible overall. So this is another chart. I'm not going to get into the details. It's the same type of indicators. And here is an interesting point, which is the distribution of those new space jobs in 2022 by European country, where you can actually see, I see that the chart is not fully visible. Let me extend a little bit this so that we can have all. Yes, so we can have it all visible here. Let's go back to the full screen. Okay, so here you see that basically most of the new space is happening in the UK, which is actually a really thriving environment. And this is thanks to the big efforts that have been done by the catapult system, which I believe has attracted a lot of business opportunity and establishment opportunities in the UK. It's followed by Germany. And here you can see that in Germany, there is a good balance between actually transportation and manufacturing. And Germany is really leading the game in the new space transportation segment. Then we see France, which is about half of the UK, a bit less, and still lagging behind. And then we see that Italy, Spain, Poland, Finland. So Finland is a bit specific because this is almost one single company which is producing most of the employment, which is ISI, of course. So we see that we have a lot of thriving space sectors throughout Europe. What I would like to highlight is that in some countries, like Poland, here, like Lithuania here, we have a very interesting situation where the new space is actually creating more new jobs and business opportunities than what the ESA membership is actually doing. So I think that this is an interesting thing. So it's now noon. I think I have reached the original planned slot for the presentation. I'm sorry, I couldn't go through all the subjects. I have a few more points. There is interest. I believe that you may have time limitations, so I don't know if I should go on a little bit. The two more points I wanted to address was, I think that the most important one should be to have a look at what we call the global space economy figure. So if you have 5 or 10 more minutes, maybe we can go through that. I don't know if there is any issue with that. So if you should leave, do not hesitate to do so. Okay. So let me go to this part of the presentation, which is this difficult point, which is the global space economy. When I'm saying it's a difficult point, it is because it has now become a commonly quoted figure. Yes, Charles?
Yes, there's a question from Anna Maria.
Anna Maria?
No, I'm trying to put a sample that was okay to go on.
Okay, thank you very much. So yes, the global space economy. So why am I talking about this? I'm talking about this because you may all have seen this already. So this chart, which I'm sharing with you here, is produced by Bryce Technology, which is a major consultancy producing a lot of work for customers, mostly NASA, but also the Satellite Industry Association. And Bryce has been publishing quite consistently what they usually called the commercial space industry market. Eventually, this thing evolved into global satellite industry revenues, and this assessment, which has been made by Bryce consistently for the past more than 20 years now, I have statistics on my computer sitting there, has also been used to actually produce a higher level figure, which people usually call the global space economy, which you actually see sitting here in the middle. So the chart is called Global Satellite Industry Revenues, but here is called the global space economy. So the global space economy is an accumulation of data sets in which you have what they call satellite services here, 180 billion, what we call the ground equipment, which is at the same time network equipment, what we were discussing at the beginning, you know, the gateways and so on, but also consumer equipment, the terminals that people are using. Then there is the value of the satellite manufacturing here, the value of the launch, and then there is... Yes, please.
You are not sharing the slide.
I'm not sharing. Okay.
Yes.
Sorry for that. Why is this? Because it looks like I'm sharing. Let's start again. Share. Oh, you're right. Share. Sorry, I'm starting up again. Microsoft PowerPoint. Is it sharing now? Yes. And so let's go back to this.
Yes.
And putting in full screen. So yes, so I'm sorry for that. I thought I was sharing. So the figure I was talking about is this one, the global satellite industry revenues and the global space economy from Bryce. So this has been the starting point. Without Bryce, we wouldn't even have the term global space economy used at all. And this global term here includes 3 main budget items. One is the value of what they call satellite services. One is the value of what they call the ground equipment. Then there is the value of satellite manufacturing, which is very small, actually 14 billion, okay? Then there is the value of launch. And then there is the value of what they call the non-satellite industry, which is basically the accumulated value of government space budget, okay? So this figure here is actually a patch up of other data which is assessed elsewhere. So the satellite services, for instance, they include the value of satellite TV. So the direct to home, the pay TV. Then they also include the value of satellite radio. And then they include also the value of direct to home broadband service. Okay. Then there is what they call the enterprise business, what they call the transponder agreements, the managed services, you know, for broadcast, and then the mobile value and data for the MSS, the mobile satellite service. Okay. So this piece of information, which they actually accumulate to $118 billion in 2021, is already a misconception. As I said many times, the value of satellite TV, pay TV, is basically the value of contents. So it has nothing to do with the value of space. On the other hand, the companies which are using broadcast by satellite, they are generating this revenue here of 17 billion. So accumulating the revenue of the satellite TV companies with what they are paying for satellite broadcast service is actually counting twice the same value. This is only one of the major flaws. I don't want to go into the details right now because I have a chart to describe the problem. So this figure here has been setting a new trend. So today, Euroconsult is also producing their own assessment of the space economy. And basically, it is using the same methodology and is producing more or less the same figure. So nobody knows why they should do it unless, you know, they believe it's a market point for them to be able to sell the same thing. But if you look at the values, it's more or less the same, with a few big difference here in the value of manufacturing, 4 billion, and the value of launch service, 1.7 billion, compared to Bryce, 13 billion for some manufacturing and 5.7. I think that Euroconsult is closer to reality if we consider only the commercial space business. And then we have this one. This is from Morgan Stanley. And what is interesting here is that Morgan Stanley is actually using the Satellite Industry Association, so the Bryce dataset, to assess the value at some point in time. And then they do their own whatever assumptions to actually create a projection to 2040. So we started with the global space economy figure a few years ago that said it's between 300 and 400 billion dollars a year, which, okay, makes sense, doesn't make sense, not a problem. But then Morgan Stanley takes this figure and stretches it out to 2040 to produce this big 1 trillion figure for the global space economy, which has been used to baseline a number of projections for juicy markets coming up in the future. And this has been really a trend-setting figure, and this has been a transformational moment. This global space economy projection was published in 2016-17, and since then it has been copied, misrepresented, and quoted everywhere. And I would like to attract your attention to the fact that this figure here at the very beginning is actually the figure of Bryce. It's exactly the same, and basically it is sourced from Bryce. But the projections they make, they add a few points which are their own making. And for instance, Morgan Stanley, to create the 1 trillion figure, they add what they call, and you can see it in light green, second order impacts. So this is not defined in the paper. Nobody knows what it's about, but those second order impact, which are added on top of the global projection they are making, which is a linear growth projection, okay, they transform the linear growth into exponential growth. But I insist upon that. Nobody has any good idea of what do they mean. So I think that this projection doesn't really make a lot of sense because of this added figure on top, which we don't understand. On the other hand, this Morgan Stanley projection of the future, if you look at the key points which are interesting for the spacecraft manufacturing industry and the launcher manufacturing industry, which is the value of satellite launch, and the value of satellite manufacturing. So the light green, the other light green, and the light purple, basically they're bundled here somewhere in the middle. Rightfully enough, Morgan Stanley doesn't believe there is any big growth opportunity for satellite building and satellite launch. And this is one of the most distressing points, because this projection has been consistently used to support the notion that there would be a major growth in satellite infrastructure deployment in the future, a major growth in value. This is completely unrelated to this chart. So the same people who use this chart to sell their project as a project with major prospects are actually have not understood the chart itself. But the problem is that the global value, the 300 billion or 380 billion figure of Bryce, is actually an accumulation of data which really doesn't really sit well together one with the other, because basically this chart accumulates different levels of figures that go from the upstream to the downstream. Going to the downstream, the biggest point in the figure is actually the value, again, of multimedia content distributed by satellite. And again, as an example I've been taking many, many times already, if you are into the postage business, so basically your business is actually transporting letters around the world, your business is the value of the stamps you can sell. The value of the contents of the letter, if people put a love letter, or if people put a check in the envelope, for you it makes no difference. What you are transporting is a volume, a size, a mass. And for this, you generate a revenue. The DTH TV value here is basically the value of the contents. Similarly here, the satellite radio is the value of the contents. The postage price paid is actually included in this figure here that they call satellite communications. So the companies who need to distribute this value here, they buy the service here. So clearly here we have a different figure which is actually included in this one. Okay. Similarly, the other two very big value points on this assessment, the 386 billion assessment that Price is producing every year, they're associated to ground station and equipment. This is an assumed value of the terminal market, which is in the order of a couple of billions every year, plus the accumulated value of direct-to-home, dishes, cell phones, etc., which are actually rolled out every year. So all of that big lumpy figure here, and most of that is associated to the widespread use of GNSS chipset in cellular phones, in Fitbits, and in other appliances. So clearly, I believe that this terminal value here is actually not really related to space infrastructure business. And here, as far as position, navigation, and timing, and again, we look at the three big lumpy sums that make the total of 386 billion. This is the value of the apps which are using GNSS signals to operate, such as Waze or Citymapper and those kind of apps. And again, I don't know exactly how this value is calculated, but that's their estimate of the value of those geolocalization-driven apps. So you see three major value points in this very big billion-esque figure, which to me are just induced markets, and they can grow without growing the value of the satellite infrastructure or the value of the launch infrastructure. So again, a lot could be said from the methodological point of view of this chart, but clearly, I think that if you see anybody using this assessment undiscriminatingly, saying because there is a big value here, then there is a big potential for launch services or manufacturing business to actually increase, I think that you should really look at that kind of study with a critical eye, because I think that they have not understood well the dynamics of space markets so far. And yes, I saw a question in the chat from Agnès. You said, do I have my own assessment? I do. I can actually share it with you. It will take a little bit to actually go through it. But if we want to measure, I would say in a consistent way, the space economy, there is a very simple schematics which we can have. We have the supply side for the satellite and launch infrastructure. So you have people building launchers, people making ground systems for launch. So you have the tracking station, the ground operation centers, etc. You also have a supply chain for spacecraft systems, and you have a supply chain for spacecraft ground segment. And clearly, all this is a very complex supply chain, which includes very large players, Boeing, Lockheed in the USA, SpaceX, of course, which are doing all the segments there. We also have Airbus, Thales Alenia Space, but we also have equipment suppliers, people which are specialized in the ground segment. I don't want to go all the details, but those are the main players on the supply side. On the demand side, you have the spacecraft operators, Eutelsat, Intelsat, Inmarsat, but also Planet Spire, integrated ones. You have civil space agencies, and you have military space agencies or military space users for space infrastructure. Somewhere in the middle, you have the launch services operators, which are buying launch systems and selling the launch service. Again, sometimes it can be an integrated company, whereas, for instance, SpaceX is at the same time a launch system supplier, a spacecraft system supplier, a ground system supplier, a launch service operator, and the spacecraft operator. So all those functions are found within a single company. The idea is that the players on the left-hand side here, they represent the upstream industry. It is also the suppliers of satellites and spacecraft and launchers. On the right-hand side, here you see the demand side. We can also call it the midstream. And then we see that the spacecraft and ground segment manufacturers, they sell to operators, to agencies, military and civil. So this is the main market segment. We also see that the launcher industry is selling to the launch service operator. At the end, I will put the figures on all that. We also see that the launch service operator is selling to the spacecraft operators and to the civil and military agencies. So you see here, you already see a level of consolidation in the supply chain. And of course, there is a specific area where the launcher system supplier and the launcher ground segment supplier, they're actually selling directly to the operators, to the agencies, because there is a point of market there, which is quite specific, where they sell R&D and those type of activities. We also have, in the industry side, on the upstream side, some companies which are specialized in making test benches, in providing special appliances to the upstream sector, which are needed to produce the satellites. So those are included in the upstream supply chain. And of course, they are selling those to the manufacturing industry. And then at the bottom, you have the value of the induced market for the global space economy. And I will now start putting figures on all this. So first, we need to look at the demand. My assessment is that globally speaking, the total business associated to the institutional segment so far, civil and the military, is in the order of $110 billion every year in recent years. This is mostly driven by the demand from the USA and China, of course. Again, order of magnitude, the European value within those budgets is in the order of 10 billion. So Europe is about 10% of the total institutional space infrastructure demand worldwide. The business associated to spacecraft operators, the commercial ones, is in the order of $12 billion. So this is the total revenue they have available to actually buy launch services and to actually buy the satellite infrastructure. The total launch business itself, as I showed before, is in the order of 9 to 10 billion a year. Okay, and a part of that business, of course, is driven by commercial launch demand. Most of the business to launch is associated to the needs of the institutional programs. When we look at the supply side, you see how this total demand, which is actually 60 plus 50 plus 12. So this is the total available demand to fund satellite infrastructure worldwide, it is split between rough points here, the ground segment suppliers, and here I'm not talking about the terminal. This is my assessment of the global gateway and satellite operation centers is in the order of 8 billion a year. The spacecraft system market is in the order of 64 billion a year, of which about 50 is associated to complete systems deployed in orbit, and the remaining 14, maybe 15 billion dollars a year is associated to this other part of the market, which is R&D, studies, and this kind of business that you all have with your main space agencies. The total launcher business in the order of 12 billion a year. Again, 9 billion goes to producing operational space systems, and then in the order of 3 billion, maybe 4 billion a year is associated to R&D and consolidation activities. So it is the business driven directly by the civil and military space agency. And then there is a ground segment for launcher activities, which is in the order of $1 billion a year in my estimate, but this is really a rough ballpark estimate. It's not a detailed measure. And then, of course, there is within this upstream market a market of about 3 billion. So this 3 billion is the market associated to EGSE, MGSE, and those kind of businesses, including dedicated engineering activities made at the service and at the demand of the space manufacturing industry worldwide. So it is a piece of business which is integrated in the global upstream figure. So those 3 billion cannot be added to the 12, 1, 64, and 8 because they are consumed by those. If we put figures down on the downstream, basically we have, and here I'm using the figures from Bryce or Euroconsult because I don't have other sources available, but the Earth observation terminal business is in the order of 3 billion. The GNSS terminal business, and most of that is cell phones, Fitbits, and so on, is estimated at 60 billion. The telecommunication terminal business, and this is VSATs and DTH antennas, is estimated in the order of 20 billion. And then we have this value added on satellite services. This is the market of the apps, which are GNSS enabled. Again, a figure which I cannot control, but which is estimated to be 84 billion. If you put all that together, you come to a total figure of 300 billion, more or less, consolidated figure for the global space economy. Here, I just put a few pieces of text to actually explain how the money from the civil and military space agency is spent, because most of those budgets are spent, of course, on institutional programs, but not everything of those programs actually lands in orbit. There is a lot of infrastructure investment, but also R&D and technology, and also they have their own cost for operations. There was a question, or maybe more than one in the chat. Maybe you can take the micro and voice
Hello,
it, please.
Hello, everybody. Can you?
Yes, I can hear you.
Hello. Thank you for this very interesting presentation. And I just have a question about where the satellite operations, I mean, in orbit control or telemetry and TT&C services, or the ground segment operations like ILS and OPS are included in this picture.
So this is a bit of a tricky one, because here, as you can see in the top part of the picture, I'm really looking at the hardware market. So I know that today a number of companies, they actually produce or acquire gateways, control centers, and they are in the business of selling a service to the operators, but also to civil and military agencies for data uplink and downlink, mission operations, and so on. This is a business which I cannot track with these global figures here. Okay, I'm sorry for this, because we don't have any rough order of magnitude of value point to assess this one. I have the impression that globally, this is not a major point of misses. Again, when I say it's not major, I'm not saying at the level of a single company, but in the global picture, here we're talking about 280 to $300 billion a year of global space activity. And it is a subset of this one, but I don't have the details of that. I'm sorry.
Okay, thank you.
We were trying here just to build a conceptual framework, but it should be included into this demand here. So it is a subset of that demand, and it would be a subset of this supply here, where we have, as I said now, the boundaries are not very clear because some companies, they do own their own ground segment, and what do they supply is an operation package or a service package. So sometimes the frontiers are difficult to actually make, but they are driven by the demand from these guys, the operators, the agencies, civil and military.
Okay, thank you.
You're welcome. Other questions?
No, I wanted to highlight that it's true what you are saying, that is difficult to trace. But take into account that operation and maintenance are not a neglectable value as a contribution to the global market.
Of course, of course. And then, of course, they play also a significant role in the way the sector is structuring itself. So indeed they play. But the core point is that you don't have a market for operations if you don't have a market for the infrastructure. And this is also why I believe it's always interesting to look at the key entry point indicator here, which is how much satellite capacity we're putting in orbit. Because there is a dimensioning factor. The more satellite capacity will create more business opportunities at all levels of the supply chain. But the other way around is not always true. And I insist a lot on that. If tomorrow Sky Television decides to charge more for the monthly subscription for movies, sports, etc., then the value generated by that business will grow without changing anything with the value created at the level of the spacecraft operator business, which is actually SES, which is offering broadcast service to Sky. So there are some points of business which are unrelated. Again, my predicament is the following. If you have more satellite infrastructure, you will have more demand for launch and eventually, potentially, more value in the induced markets here below. In particularly, if you have more capacity to sell in broadband, there will be more sale of telecom terminals. If you have more capacity in Earth observation system, you will have more people buying terminals to download directly the data. This is mostly military terminals. And you also will have more data and value-added services on Earth observation. So you see, more satellite infrastructure will generate, with a domino positive effect, more demand in all layers of the supply chain. And this is not always the case. For instance, if you look here at the value of GNSS terminals, we all perfectly know that more and more devices are GPS Galileo enabled. But they don't need more satellites to work in orbit. The GNSS infrastructure is dimensioned once and for all, and everybody can use the same signal. So the growth in those induced markets is not necessarily an indicator of future growth in the satellite infrastructure. And this, again, has been, from my point of view, one of the major analytical short points of this global space economy figure that has been presented and overhyped in recent years. Because they were showing growth. Most of the growth was fueled by the induced markets, and it didn't generate any growth in the upstream and the midstream. So the two are unrelated. Okay? So I don't know if there is any more point of discussion. Again, I can be available, but you may have a strong agenda and constraints. So I will stop sharing the